For this expression, we'll factorise it using a grouping method of 3 and 1. So we have 4x squared plus 12xy plus 9y squared minus 16z squared. And when there's more than 3 terms for a quadratic, or any type of factorisation that you're doing, you just need to look for patterns or common factors that are hidden within the terms. So if we look at the first 3 terms of this, we can actually identify that it's a perfect square. So the first term, 4x squared, is actually 2x all squared, and the 9y squared is actually 3y all squared. Looking at the middle, the 12xy is actually the same as twice the outer term's square roots multiplied together. So that is, it's equal to 2 times 2x times 3y, which you'd see would give the 12xy that we see in the middle of the perfect square above. The last term over here, the 16z squared, is also a square term of 4z all squared, and we'll come back to that a little bit later. So the first thing we're going to do is we're going to factorise the first 3 terms as a perfect square. So the perfect square will become the first and last terms, their square roots added together. So that's the 2x, and we add on to that the 3y. So we have 2x plus 3y all squared, which gives 4x squared plus 12xy plus 9y squared when it's expanded. And then onto that, we've got minus, and it's going to be 4z all squared, because that's the same as the minus 16z squared we see. So now we can see that this is in fact a difference of perfect squares, because we've got a square minus another square. And whenever that occurs, we know that it's the difference of perfect squares. So we can factorise according to that expansion pattern too. So to do that, all we do is we take the first square and we have 2x plus 3y and 2x plus 3y. And in the first one we add on 4z, and in the second one we subtract 4z. So overall, the expression 4x squared plus 12xy plus 9y squared minus 16z squared can be factorised as the expression in the box here.